In this question, we're asked to, we're learning how to evaluate logarithms. So the first question asks us to evaluate the log base 2 of 1/8. Another way of writing this question is to say x equals log base 2 of 1/8, and now evaluate x. Well, if we write it this way, we can quickly put it into an equivalent exponential form. To say x equals log base 2 of 1/8 would be the same as saying the base of the logarithm becomes the base of the exponent. 2 to the x is equal to 1/8. And now all we have to do is figure out what x would equal. Well, we know 2 to the 3 equals 8. So by extension, 2 to the negative 3 is equal to 1/8. So therefore, the answer is the log base 2 of 1/8 is -3. And that is our final answer. Now, if you want to see it typed out nicely, here is a nicely typed out explanation. You're looking for the exponent that goes on the 2 to give you 1/8. And so the answer is that red -3. Okay? Well, how about this? What if we're asked for log base 49 of 7? Well, let's write it this way. The log base 49 of 7 is equal to x. Now let's solve for x. Well, re-expressing our logarithmic as an exponential, we get 49 to the x is equal to the 7. Well, we know that the square root of 49 is 7, so that means 49 to the 1/2 is 7. So in other words, our x value must be 1/2. The exponent of 1/2 gets put on 49 to give us 7. So therefore, the log base 49 of 7 is 1/2. And that's our answer. Now we can write it out nicely typed out if we want. And like it says there in red, the log base 49 of 7 is 1/2 because 49 to the 1/2 is 7. Okay? So you're asking yourself in these questions, what's the exponent that goes on the base of that logarithm to give me the answer? Okay, well, here we go. We've got, if we say the log base 81 of 1/3 equals x, then that would mean by extension that 81 to the x is equal to 1/3. Well, if you have good number sense, you know that the fourth root of 81 is 3. In other words, 81 to the 1/4 is 3. Well, that would mean that 81 to the -1/4 is 1/3. So we've just figured out our answer. Since 81 to the -1/4 is equal to 3, therefore the log base 81 of 1/3 is -1/4. And there's our answer. And so to show that typed out, you could write it that way. Ultimately, the log base 81 of 1/3 is -1/4 because, as you see in red, 81 to the -1/4 ultimately equals 1/3. Well, what if we're doing the log base 1/5 of 125? Well, that would be like saying the log base 1/5 of 125 is x, so therefore 1/5 to the exponent x is 125. Now, we know that 5 to the 3 is 125. So when we take the reciprocal of that base of the exponent, we then make the exponent negative. So since 1/5 to the exponent -3 is 125, therefore the log base 1/5 of 125 is -3. Okay? And the answer to this question is -3, and the reason for it is as shown, typed out for you right there. Okay? How about the log base 1/4 of 1024? Well, a little bit of thinking here. We know that 4 to the 5 is equal to 1024. So that means 1/4 to the exponent 5 is equal to 1/1024. Well, we have our answer right here. Since 1/4 to the exponent 5 is equal to 1 over 1024, therefore the log base 1/4 of 1024 must be equal to 5. And that's our answer, 5. And the reason for it is shown here, typed out, if you like to see that. Again, what we're doing is we're saying to ourselves, what exponent do I put on this number right here to give me this number right here? What if I'm looking for the log of 1,000,000? Well, you say to yourself, well, if I let x equal the log of 1,000,000, that's like saying x is the log base 10 of 1,000,000. So now what I'm doing is I'm saying to myself, 10 to the x is 1,000,000. What does x equal? Well, we know that 10 to the 6 equals 1,000,000. In other words, 10 times 10 times 10 times 10 times 10 times 10 is 1,000,000. So since 10 to the 6 is equal to 1,000,000, therefore the log base 10 of 1,000,000, or just the log of 1,000,000, is 6. And again, remember, when you see that word log and there's no base, the base is assumed to be a 10. Okay, and there's the thinking. Like it says, the red digit near the bottom of the page, 10 to the 6 equals 1,000,000, so therefore the log of 1,000,000 is 6. What if we want the log of 0.0001? Well, again, that would be if we said the log of 0.0001 equals x, we'd be saying the log base 10 of 0.0001 is x. That would be like saying 10 to the x. The base of the exponent is the base of the, the base of the logarithm becomes the base of the exponent. So 10 to the x would be equal to 0.0001. And this means x is -4, because 0.0001 is equal to 1 over 10,000. Since 10 to the 4 is equal to 10,000, therefore 10 to the -4 is equal to 1 over 10,000. Okay, so there's a lot of free-flowing thinking going on there, but it ultimately means 10 to the -4 is 0.0001. And from this statement right here, since 10 to the -4 is 0.0001, therefore the log base 10 of 0.0001 is -4. And that would be the answer when asked to evaluate. And there's the thinking put in front of you right there. Okay? So, hopefully you're getting the hang of this. Now, as we see here, we're going to take the log base 2 of -8. Well, let's say we let the log base 2 of -8 equal x. That would mean that 2 to the x is equal to -8. Well, 2 to the x, that would mean that we're multiplying 2 by itself a number of times to come up with -8. But if you multiply a positive number by itself a few times, it'll never become a negative value. In other words, this is impossible. So there is no solution to this question. And that's what it says here. X equals log base 2 of -8 would mean that 2 to the x is equal to -8. But it's not possible for a power with a positive base to equal a negative number. So there's no solution. Now, recall earlier we agreed that the base of a logarithm must be positive. Since it's not positive, therefore, in red, what we say here is we cannot have a logarithm with a negative argument. In other words, the value that we're taking the logarithm of cannot be negative. So anytime that you're determining a logarithm, the thing you're taking the logarithm of, which in this case is -8, we call that the argument, that cannot be negative, and it cannot be 0 either. It must be positive there. Okay? Now, Let's use a calculator now, and we're going to solve for x rounded to 2 decimal places. We're saying 10 to the x is equal to 86,209. Well, 10 to the x equals 86,209. If I want to isolate the x, I can say that x is log base 10 of 86,209. Okay? And these two formulas these two equations that you see in front of you are the flip side of the same coin. Those two equations literally mean exactly the same thing. So you need to be able to state it both ways. Now, your calculator has a log base 10 button. Specifically, it's the one that just says log. So x is going to equal the log of 86,209. So if you get your calculator out and figure out log 86,209, it'll come up with the answer roughly 4.94. So the answer is 4.94. 10 to the 4.94 is roughly equal to 86,209. And you do that by using the logarithm button on your calculator. What if we want to evaluate the log base 8 of 1? Well, the log base 8 of 1 equaling x would mean that 8 to the exponent x is equal to 1. Well, actually, we know the answer to that. The answer is 0. Since 8 to the 0 is equal to 1, therefore, the log base 8 of 1 must be 0. So the answer is 0. Okay? And that's the thinking shown typed out on the slide right in front of you there. Okay? So generally speaking, the log base a of 1 is equal to 0, assuming there that the base of the logarithm is greater than 0 and doesn't equal 1. Now, what if we're evaluating the log base 3 of 3 to the 7? Well, this is kind of cool. Remember what this means. If we let the log base 3 of 3 to the 7 equal x, we're evaluating for x, that means 3 to the exponent x is equal to 3 to the 7. Well, just by observation, just look at this equation with fresh eyes. Obviously, x must equal 7. Has to. 3 to the 7 equals 3 to the 7. So the answer to this question is 7. So x equals log base 3, 3 to the 7 means 3 to the x equals 3 to the 7. Therefore, the answer is 7, like I said a minute ago. And we can come up with a general statement here. The log base a of a to the x is equal to x, assuming a is greater than 0 and a doesn't equal 1. Now, how about how about 5 to the exponent log base 5 of 125? Well, the first thing we should do is figure out what does the log base 5 of 125 equal. So let's let the log base 5 of 125 equal x and solve for x. If we write this equation out like this, then we're saying 5 to the exponent x equals 125. Well, this would mean that x is equal to 3, because we know 5 to the exponent 3 is equal to 125. So the log base 5 of 125 is equal to 3. So let's take this right here and replace that exponent, log base 5 of 125, with 3. Well, what is 5 to the 3? 5 to the 3 is 125. So in other words, we've just shown 5 to the exponent log base 5 of 125 is equal to 125. And it seems like we're going around in a big circle, but what we have there is one example of a rule that we're going to say is a general rule. And we're going to say that generally speaking, when we have something like 5 to the log base 5 of 125? The answer is 125. In other words, a to the log base a of x is x. And that'll become a rule that'll come up one or two times, maybe more than that, in your homework or maybe on a test. So that's a rule that we're going to want to learn later in the section. We'll have a list of rules, and that'll be one of them. Okay, so we can write that out in red. A to the log base a of x will equal x, assuming, of course, as said earlier, a is greater than 0, x is greater than 0. We said a few slides ago the argument has to be greater than 0, and a can't equal 1. What if we've got the log base 3 halves of 81 over 16? Well, if we let this equal x, then we're basically saying 3 halves to the exponent x is equal to 81 over 16. Well, we actually know that 3 to the 4 equals 81 over 16. Sorry, we know that 3 to the 4 equals 81, and we know that 2 to the 4 equals 16. So that means that 3 halves to the 4 is equal to 81 over 16. Well, if 3 halves to the exponent 4 is equal to 81 over 16, then the log base 3 halves of 81 over 16 must be equal to 4. And that's our answer. And this is what it says on the slide here, if you like to see it typed out. Okay. What if we're looking at the log base 3 of 243 to the negative 6 over 7? Okay, this looks pretty tough, but it's helpful to remember that 243 is really just 3 to the exponent 5. So what we're saying is we've got the log base 3 of 3 to the 5 to the exponent negative 6 over 7. And now we look at this. What we've got here is a power that is raised to another exponent. The power 3 to the 5 is raised to the exponent negative 6 over 7. And we remember that all we do is multiply those exponents. So we multiply 5 with negative 6 over 7. We get negative 30 over 7. So what we have is the log base 3 of 3 to the exponent negative 30 over 7. Now when we write this, if we say that this is what x is equal to, then what we're really saying is that 3 to the exponent x is equal to 3 to the exponent negative 30 over 7. And just looking at it by observation, we can say, okay, therefore x must be negative 30 over 7. So the answer to this question must be negative 30 over 7. Okay, and this is what we do. This is it written out in a nice typed form. We know 243 is 3 to the 5. So therefore 243 to the negative 6 over 7 is 3 to the 5 to the negative 6 over 7. Multiplying those gives us 3 to the negative 30 over 7. So then when we say the x equals log base 3, 243 to the negative 6 over 7, we're really saying log base 3, negative 30 over 7. And we know this expression right here, if we say what is the log base 3 of 3 to the negative 30 over 7, again, I'm repeating myself, I know, but if we let that equal x, then putting it in an exponential form is like saying 3 to the x equals 3 to the negative 30 over 7. And so by observation, x must be negative 30 over 7. Okay? So basically what we're saying is ultimately, if you just want to see it one more time, when we say that this expression is equal to negative 30 over 7, when we write this, what we're really saying is 3 to the negative 30 over 7 equals 243 to the negative 6 over 7. And this is true because 243 is equal to 3 to the 5. And when we multiply these two exponents, we get negative 30 over 7. So the statement is true, And so our answer is negative 30 over 7.